Welcome prep 3 students. The first unit in our curriculum this year is physics, and it's very interesting branch of science. The first lesson is motion in one direction. Motion is the action or the process of movement, and in physics, motion is a change in the position of an object over time. If the position of object is not changing, the body is said to be at rest state. So we can say that motion is a change in the object position as time passes according to another object. So if the object changes its position, so it is in a state of motion. Of course, motion happens all around us. Everywhere we can see objects move, such as cars, planes, peoples, balls. So it happens all over or all around us. As we said, that motion is a change in the position of object as time passes. The path of moving object may be curved or straight, or it may combine both curved and straight. The simplest type of motion is motion in a straight line in one direction. So the simplest type of motion is the motion in a straight line in one direction. We have give reason question here. Give reason. The motion of the train is considered from motion in one direction. The first give reason in our lesson. Motion of train is considered from motion in one direction. Why? Because because the train moves forward and backward, but it doesn't move upward or downward. So motion of the train is motion in one direction because the train moves forward and backward, and it doesn't move upward or downward. Then we will move to the next part, which is the speed. We can describe the motion of some objects around us as fast or slow. So we can say that the speed is the physical quantity that distinguishes the description of objects, either fast or slow. So we can describe the motion, if it is fast or slow, by the speed of objects. For example, if we have two cars, they move on the same road, where the first one takes shorter time than the second one to cover the same distance. The first one takes shorter time than the second one to cover the same distance. Which of them is faster, the first one or the second one? Of course, the first one is faster than the second one because it takes smaller time to cover the same distance. Another example, if we have two cars and they cover different distance at equal time, the first one covers longer distance than the second one. Which of them is faster? Of course, also the first one, because it covers longer distance in the same time. So from these two exercises we can discover that, or we can conclude that the two factors which are necessary for describe motion. What are the two factors that are necessary to describe the movement or to describe motion? Of course, distance and time. So we can describe motion by using two factors, which are the distance covered by the moving object, the time taken by the moving body to cover this distance. Distance and time are the two factors that are necessary for description of motion. So now we can identify speed. Speed is the distance covered by object in a unit time. Unit time, it may be second or hour, and distance measuring unit is kilometer or meter. So again, speed is distance covered by object in a unit time. We can also say that speed equal distance divided time. Speed equal distance divided time. Focus with me. The speed of object is inversely proportional with time. It means that the object speed increase as time decrease. It is inversely proportional with time. The object speed increase as time decrease to cover the same distance. And also the speed is directly proportional with distance. So we can say that the object speed increase by increasing the covered distance. If you remember, the car which cover longer distance has higher speed, so it is directly proportional. When the distance increase, the speed increase. And also the car which takes less time is faster, so it's inversely proportional. When the time decrease, the speed increase. The speed of the object is inversely proportional with the time and directly proportional with the distance. What are measuring units of the speed? If the distance covered by meter and time seconds, so the measuring unit will be meter per second. But if the distance is measured by kilometer and the time is measured by hour, in this case the measuring unit is kilometer per hour. So we can say that the measuring units of speed are meter per second or kilometer per hour. To change from kilometer per hour to meter per second, we have to multiply 5 divided 18. If we have the speed with the unit kilometer per hour and we want to change it into meter per second, we have to say the speed times 5 divided 18. But if we have it by meter per second and when we want to change it into kilometer per hour, we will multiply by 18 divided 5. So to change it from kilometer per hour to meter per second, 5 divided 18. To change it from meter per second to kilometer per hour, 18 divided 5. We will have a small example. Calculate the speed of the swimmer who swims 120 meters in 60 seconds. So we have to underline 120. It is the distance covered. And we have also to underline 60 seconds. It is the time taken. So we can say that the speed equal distance divided time. So it is 100, or it will be 120 divided 60. It is 2 meter per second, because the distance covered is by meter and the time is measured by seconds. So again, speed equal distance divided time. It will be 120 divided 60. It will be 2 meter per second. If we want to calculate the distance, we can say that the distance equal speed times time. If we want to calculate the speed, it is distance divided time. If we want to calculate the time, it is distance divided speed. Let us revise. Motion is a change in the object position as time passes according to another object. The simplest form of motion is motion in a straight line in one direction. The train is an example of motion in one direction because it moves forward and backward and it doesn't move upward and downward. Speed is the distance covered by time is distance covered by the object in a unit time. There are two factors affecting speed or affecting motion. They are distance covered by the moving object and the time taking to cover the distance. Then we will take the forms of the speed or the types of speed or kinds of speed. But first we have another question. What is meant by? What is meant by a car moves with a speed 120 km per hour? What is meant by a car moves with a speed 120 km per hour? This means that the car covers 120 km each 1 hour. What is meant by a car moves 150 km in 2 hours? 150 in 2 hours. It means that the car covers 75 km per hour. It covers 75 km per hour. Then we will move to kinds of speed. There are two kinds of speed. The first one is uniform speed or regular speed. So the first kind of speed is uniform speed. We can say that when the car covers equal distance in equal periods of time, we can say that this car moves in a regular speed. But how can we measure the speed in the car? We can say that the cars are provided with a group of counters. This is an example of counters, such as speedometer, mileage, and compass. So cars and the planes are usually provided with a group of counters such as speedometer, mileage, and compass. These devices are used to measure the speed of the car. If the car moves equal distance at equal periods of time, so we can say that this car moves in regular speed or uniform speed. For example, if the speedometer in the car points to 72, this means the speedometer points to 72. This means that the car covers 72 km each hour. 72 km each hour. If the reading is still constant, and that's what happens if there is no traffic. The car can move in constant speed if there is no traffic. So we can say that this reading remain constant during your traveling or if there is no traffic. So the first type of speed is regular speed, and it is the change in the object position by equal distance at equal periods of time. If we want to calculate the uniform speed, we will say that speed equal distance divided time. For example, calculate the distance covered by an object moves at regular speed 70 km per hour. So we have the speed during half an hour. We have the speed and we have the time, and he is asking me to answer or to calculate the distance. Can you tell me how can we calculate the distance? Of course, distance equal speed times time, because the speed equal distance divided time, so distance equal speed times time. So it will be 70 times half, it will be 35 meter. So the first type of speed is uniform speed, the change in the object position by equal distance at equal periods of time. The device that is used in the cars to measure the speed is speedometer or mileage. When the car moves equal distance at equal periods of time, this car is in a state of moving with a regular speed. The second type of speed is non-uniform speed. It happens when the car moves unequal distance at equal periods of time. Unequal distance at equal periods of time. Or it moves equal distance at unequal periods of time. So we can say that the non-uniform speed is a change of the object position by unequal distance at equal periods of time. Or it is the change in the object position by equal distance at unequal periods of time. But it's very difficult to determine the amount of irregular speed because it's not constant. So we use another term which is known as average speed. Average speed. If we observe a car moving on a road, we find that its speed change according to the traffic. So this case is the car moves in irregular speed because it's moving according to the traffic. It's difficult to make the speed of the car constant due to the presence of this traffic. So the car moves irregular speed, and it's very difficult to determine the value of this irregular speed. It's difficult to determine the amount of irregular speed. So we use another term which is called average speed. What is the average speed? Average speed is the total distance covered by the moving objects divided by total time taken. So again, average speed is the total distance covered by the moving object divided by the total time taken. We can calculate it by the relation average speed equal delta D divided delta T. It means total distance covered divided total time. Delta means total distance covered divided by total time. We have a problem example. A runner covers 100 meters in 10 seconds and he walks back to cover the same distance in 80 seconds. So he runs to cover 100 meters in 10 seconds and he returns back walking to cover distance, the same distance of course, which is 100 meters in 80 seconds. Calculate the racer's average speed while running and its average speed during walking and during the whole trip. Let's start with the racer's average speed while running. The average speed is distance divided time. During running, he covers 100 meters in 10 seconds. So we can say that the racer's average speed during running equal D divided T equal 100 divided 10 equal 10 meters per second. During walking, he covers the same distance, which is 100, but in 80 seconds. So it will be D divided T, 100 divided 80. The racer's average speed during walking equal D divided T, 100 divided 80. So it will be 1.25 meter per second. Finally, the average speed during the whole trip. It means total distance covered per or divided total time. The total distance covered is 100. Running, he runs 100 and walks 100. So the total distance covered is 200 meters. What about the total time? During running, he covers the 100 meters in 10 seconds. During walking, he takes 80 seconds. So total time will be 90. So we can say that the racer's average speed during the whole trip equal 200 total distance divided 90 total time. It will be 2.2 meter per second. We can say that when the average speed of a moving object equal regular speed, if the average speed equal the regular speed, so we can describe the motion as regular motion. If the average speed equal regular speed, so this body is moving a regular motion. When the average speed of a moving object doesn't equal a regular speed, so the moving or the motion described as irregular motion. So we talked about the two kinds of speed, which are regular speed and irregular speed. Regular speed when the body covers equal distance at equal periods of time. Irregular speed when the body covers equal distance at unequal periods of time. We can't determine the value of irregular speed. It's difficult to determine the amount of irregular speed, so we use another term, which is average speed. We said that average speed is the total distance covered by the moving object at divided by total time taken. We have a question. What is meant by the average speed of a moving object is 40 km per hour? We can replace the word average speed with its definition. I will say the question again. What is meant by the average speed of a moving car is 40 km per hour? It means that the result of dividing the total distance covered by the car by the total time taken to cover this distance is 40. Again, the result of dividing the total distance covered by the car by the total time taken is 40. So what is meant by? We replace the word with its definition. Then we will talk about relative speed. We can say that it is the speed of moving objects relative to an observer. The speed of moving objects relative to an observer. And we can calculate it as the following. It means that the measuring of the speed depends on the position of the observer. So the speed change by changing the position of the observer, who determine the magnitude of the observer. Let's see. We will say that if the observer is at rest state, in this case only the relative speed equal the real speed of the object. It means if the observer is at rest state, so he will see that the speed of the moving object is the real speed. But if the observer in a moving car or in a moving object that moves in the same direction, if the observer is moving in the same direction with the moving objects, for example, the observer is in this car, the red car, and he is watching the other car. The two cars are moving at the same direction. In this case, we will say that the relative speed will be the object speed minus the observer speed. The object speed minus the observer speed. But if the observer is in moving object in opposite direction, if the observer is moving in the opposite direction of moving object, in this case the relative speed equal object speed plus observer speed. So relative speed is according to the place of the observer. If the observer in rest state, the relative speed will be the real speed of the moving object. If it moves in the same distance with the moving object, the relative speed will be the object speed minus the observer speed. If they are moving in opposite directions, relative speed will be object speed plus observer speed. The last question today: what is meant by the relative speed of a moving object to another observer? The relative speed of a moving object to an observer equal its real speed. If the relative speed equal its real speed, what is meant by this sentence? It means that the observer is in rest state. Thank you very much for listening. See you in the next lesson. Thank you.